Hello everyone, welcome back to another video. I know it's been a while. Oh yeah, Happy New Year's too. Yeah, a lot of stuff has happened. Been out of country, school started back up, and the workload's gotten pretty bad. I kinda broke my old mic, so I'll be using this new one. But at least I can upload right now because it's winter break. But I'll try to keep up a reasonable schedule afterwards too. Also, sorry if I don't sound too great, I'm slightly sick right now. But yeah, anyways, looking at the title, you guys already know what this video has been about. It's part of a new series I'm making all about digital logic. We'll start off today by talking about number systems, which will include decimal, binary, octal, and hexadecimal. So without further ado, let's just get straight into it. Okay, so let's start off by talking about decimal. This is the normal base 10 number system that we're all used to using, so it's easiest to explain how all of the other number systems work using decimal. Okay, so basically, let's look at one digit. We start at 0, go 1, 2, 3, 4, 5, 6, 7, 8, 9, and then the second digit becomes a 1 again, right? So this is called a decimal system because you have 10 different values that one digit can have, before you have to make another one. Another way to look at this is as different powers of 10 being multiplied to create your values for each digit. Now I know that sounds complicated, but let me explain. Let's look at your first digit again, as 10 to the power 0 times whatever your number is. Now let's say that that is 7. 10 to the power 0 is 1, times 7 gives you 7. Let's look at a more complex number for this. Let's look at 39. This can be written as 10 to the power 0 times 9, plus 10 to the power 1 times 3, and those values added together give you 39 again. Instead of base 10, this time it's base 2, but everything else is the exact same though. So let's just look at one digit again, and you can only have 0 or 1 as the value, so you can't represent nearly as many values with just one digit. This digit would be 2 to the power 0 times your value, which can be either 0 or 1. So let's add a second digit now. Instead of just representing 0 through 1, you can represent a maximum of 0 through 3. Now let's say we have 11 in binary. That's 2 to the power 1 times 1, plus 2 to the power 0 times 1. Add that together and you get 3. Another way to look at it is that since each value can only be a 0 or a 1, you can think of that digit as a switch. You turn that switch on, and that value is added to your total. For example, let's say you have 1101. Look at each digit. 1 is active, 4 is active, 8 is active, and when you add all of those numbers together, you get 13, which is the decimal value of that binary number. First, let's cover basic facts about them. Octal is base 8, and hexadecimal is base 16. Octal goes from 0 through 7, and hexadecimal goes from 0 through F. With hexadecimal, you have to be able to fit values above 10 into a single digit, right? So we use letters to determine numerical values. A is 10, B is 11, C is 12, and on up until F, which is 15. Converting a number to octal or hexadecimal can be done directly, but you can also use the intermediary step of converting to binary first and then to octal or hexadecimal. This is probably going to be much easier, and this is the method that we'll be covering in the next section. So the easiest method to convert a decimal number to binary is just to subtract. This gets easier as you do it more, but basically what you want to do is find a number that's a power of 2, right? 1, 2, 4, 8, 16, 32, etc. And then just keep subtracting these numbers until you get to 0. Let's do an example number together with 29. The closest power of 2 to 29 is 16. 29 minus 16 gives you 13. Now make the 16 slot a 1, and the next closest number is 8. 13 minus 8 gives you 5. Make the 8 slot a 1 as well, and next up is 4. 5 minus 4 is 1. Make the 4 slot a 1 as well. So now that you're left with 1, 2 can't go into 1, right? So that leaves the 2 slot as a 0, and 1 does go into 1, giving you 0. And so then, if you put all of this together, your final number in binary should be 11101. And binary to decimal is reliant on the exact same principle, so we can just use 11101 again to convert back. What you want to do is look at the value of each slot that is active, right? We see 1 is active, 2 is not active, 4 is active, 8 is active, 16 is active, and so you just add 1, 4, 8, and 16, and then you get 22 again. Now to convert to hexadecimal or octal, you have to take a binary number and convert sets of 3 or 4 to octal or hexadecimal. What that means is, let's say you have the binary number 1010, right? When you're converting to octal, you have to look at the first set of 3 numbers. You do this because when you write 7 in decimal, the maximum number for base 8, you have to write 111 in binary. Now let's look back at our number 1010. The first set of 3 numbers is 010, and 010 is 2 in decimal, right? So just write down 2. And then look at the set of the next 3 numbers. That's just 1, but you can look at it as 001. Now 001 in decimal is just 1, right? Put those together and you get 12 in octal. Now to convert to hexadecimal, use 4 numbers. 1010 converted to decimal is 10, which is A in hexadecimal. To convert backwards from octal or hexadecimal to binary, you basically just have to turn one octal or hexadecimal number into a set of 3 or 4 binary numbers. Let's say you had 51 in octal, right? Convert 5 to binary and you get 101. Convert 1 to binary and you get 001, since you need to still have a set of 3, and so you put those together and you get 101001. Hexadecimal is the exact same thing, but with 4 numbers instead. Let's say you had 9b in hexadecimal, right? Convert 9 to binary, that's 1001, and b or 11 to binary is 1011. Put that together and you get 1001, 1011. Alright then guys, that concludes today's episode, and in the next one we'll be covering logic gates, how they work, and how to use them. Anyways, have a great day guys, I'll see you in the next one. Please be sure to like and subscribe if you really enjoyed this one, and yeah, just have a great day. Peace.